of a cubic function, right? And I introduced the concept with the turning points, the shape of the cubic function, the point of inflection. Okay, so I hope that you went home before you went to bed last night. You went over those concepts. Because today I'm gonna apply them now in terms of sketching. So these are general rules that you can use to sketch a graph. Allow me to add the first one. The first one will be determine the shape. I would suggest that before you start sketching, determine the shape of the graph. Okay, that's the first point that I would suggest. So first thing, you determine the shape of your graph. That is whether it starts with a maximum, then a minimum, or it starts with a minimum, then a maximum. So you need to know that. So here, the value of A will be positive. How do I know that? I memorize now that if it starts as an increasing function, then A is positive. If it starts as a decreasing function, then A is what? Negative. Right? I need to emphasize to you that the cubic function, no matter what, you have to know how to sketch it and how to interpret it, because it always comes in metric papers. It's a major part of your differential calculus. Then after finding after the determination of the shape, the next thing that you have to do is find the intercept. Your y-intercept is the value of d, so you don't need to do any calculation. Identify your d. If d is 0, it means the y-intercept is going to be 0. Okay? If d is 0, then y-intercept is going to be 0. Then find the x-intercept. Now, to find the x-intercept, you need the concepts that I spoke about since Monday. Factorization of cubic polynomials, right? Using the factor theorem. Later on, I'll also show you how to use the calculator to determine those x-intercepts. The calculator is the shortest way of doing it. Then after that, you need to determine the coordinates of the stationary points or the coordinates of the turning points. These are also called the turning points. Okay? To do that, you need to know how to find the derivative, the first derivative. So you find the first derivative, you equate it to 0, you solve for x. The two x values that you get, you substitute them back into the original function. Then you get your coordinates. Then the last thing, determine the point of inflection. To find the point of inflection, find the second derivative, equate it to 0, solve for x. That x value, you substitute it into the original cubic function. Then you'll be ready to sketch. So that's what we are going to be doing in the next coming few minutes. This whole lesson is on. Right? So I'm going to follow that procedure. So here we have got a function. We are going to sketch f of x equal to x cubed minus 2x squared minus 4x plus 8. Just to remind you, the general equation of a cubic function is ax cubed plus bx squared plus cx plus d. That d, I told you last time, that's the y-intercept. This is the y-intercept. So, here, let's find our intercepts. Okay, let's start with the y-intercept. Our y-intercept there is going to be y equal to positive 8. This positive 8, that's your y-intercept. It means the cubic graph is going to pass through a point where y is equal to x. We know that x is 0 there because it's an intercept. Alright? Then the x-intercept. Now this one you have to do a calculation. Okay? Generally, there are supposed to be 3 of them. Okay? Generally, they are supposed to be 3. Okay? Maximum 3 x-intercepts. Sometimes you can have 2. Okay? There are times you can have 1. Right? But the maximum is what? 3. So, first, let's write our equation. F of x is equal to x cubed minus 2x squared minus 4x plus 8. That's the function. Well, this one here, you can factorize it. Okay, you don't need the factor theorem. It's not always that you might need to use the factor theorem. Okay, because what's the objective here is to find the what x-intercept. So I can factorize it. So if I factorize the first two terms, x squared, then we are going to have x minus 2. Once I create this x minus 2, I must also create it here. So it will be minus 4 times x minus 2. Alright? Okay? I didn't use the factor theorem, but there are times when I can, so we'll do a question like that. Then you have x minus 2 here times x squared minus 4. And that can be factorized. So you get x minus 2, another x minus 2, and then x plus 2. Now this is a very interesting graph. Okay? This is a very interesting graph. Then your x-intercept, you equate f of x to 0, it will be x minus 2 times x minus 2 times x plus 2 equal to what? 0. When you get that, it means x will be equal to 2 twice. Okay? X will be equal to 2 twice, because there's x minus 2, x minus 2. Or x is equal to negative 2. Yeah, it's a very interesting feature. I'll tell you. What that means is one of the two turning points is on the x-axis. Okay? This is a unique case. It means one of the two turning points is on the x-axis.
So you get an equation like this, you have to put x equals to twice.
Yeah. You need to show all the factors and you need to indicate that you are getting the same value of x twice. Alright, so we get here, we've got our what? Our x-intercept. Okay, we have found our x-intercept. Please take note of this. This is a very interesting property of a cubic function. Right? Then the next thing, we need to determine the coordinates of the stationary points. The coordinates of the stationary points. So I'll move on to the next page. Okay, stationary points are also called turning points. Right? So our function is f of x equal to x cubed minus 2x squared minus 4x plus 8. Right? Now, if you want to find the coordinates of the stationary points, find the first derivative. So it will be f prime of x will be equal to 3x squared. I expect you to know how to find the derivative now from using rules. So that will be 3x squared, and that will be 4x minus 4. Right? Then I'm not done. The next thing now is to equate that first derivative to 0. So I'll say 3x squared minus 4x minus 4 equal to 0. Then, if you want to solve that, wait. I found the derivative using the rules. Remember, last week we were doing rules of differentiation.
Oh!
I hope you are going over the stuff. Right, 3x squared minus 4, then it's up to you now here. You want to use the quadratic equation, you want to factorize, you can complete the square if you can, use the calculator in a smart way if you can. Now I'm going to factorize. Okay? I'm going to try and see if I can factorize it. This one here looks very complicated, but let me try. 3 times 4 minus 4, that will give me 3 times minus 4, that's equal to negative 12. Alright? Then, our coefficient of x here is a negative 4. Coefficient, I'm teaching you how to factorize, by the way. Which two factors of minus 12 add up to minus 4? Which two factors of minus 12 add up to minus 4?
Minus 16.
It will be minus 6 and positive 2. So we can write this as 3x squared minus 6x plus 2x minus 4 equal to 0. And this will give me 3x times x minus 2 plus 2 times x minus 2. That's equal to 0. And then you will get x minus 2 times 3x plus 2 equal to 0. What this means is that x will be equal to 2 or x will be equal to negative 2 over 2. Right? I'm not done. I need to determine the corresponding y values of these two x values. Because it's a point, the turning point, it's a specific point. So I need to know the x value and the y value at that turning point. Okay? So it's more like this. If the shape looks like that, I need to know what is the value of x and y here. What is the value of x and y? I found the x values. So I need to find the y value. So I have to substitute these two into the original function, this one here. I need to substitute both values here. So these two must be substituted back into the original. So they have to substitute back into the original to get the corresponding y value. So that's what I'm going to do on the next page. You following? Right? So on the next page, that's what I'm going to do. So I'll write my function. So here I'll just write, okay, I'll say when x is equal to 2, f2 will be equal to 2 cubed minus 2 times 2 squared, or you can put the squared inside this. There's no difference, okay, here. Then that will be minus 4 times 2 plus 8. If you simplify this, you get 8 minus 8 minus 8 plus 8. And that will give you a 0. The reason why you're getting that 0 is what I told, that one of the turning points is on the x-axis. And this is a hint. I'm sure you can see that this x value here, it's equivalent to this. An x-intercept is equivalent to an x value at the turning point. Are you following this? So we are going to get what? A turning point which is on the x-axis. Then, so what this means is that I can say therefore here. It therefore means that one of the turning points is going to be at x equal to 2 and y equal to what? 0. That's the first turning point. Then, when x is equal to minus 2 over 3, right? So we say f minus 2 over 3 will be equal to, it's going to be equal to minus 2 over 3 cubed minus 2 times minus 2 over 3 squared minus 4 times minus 2 over 3 plus 8. I'm trying to find the second set or pair of what? Of coordinates at the turning point. So this will give me minus 8 over 27, and that will give me, okay, I'll get a 4 times that, I'll get minus 8 over 9, and that one will give me positive 8 over 3 plus 8. Can someone simplify this to me?
156 over 27.
156?
256.
256 over?
27.
Over 27. That's close to 10. So it's
Yeah,
almost like
9,48.
9 comma something. Alright? You're going to approximate it on the graph. Alright? So what this means is my second stationary point is going to be at x equal to minus 2 over 3. The y value is going to be 256 over 27. Okay? So take note of our two turning points. These are our two turning points. Right. Now we need to find the point of inflection. Point of inflection. So it's quite a tedious process to sketch a cubic graph. That's why in most cases they will bring uh, a graph which is already drawn, but they know that it takes a bit of some time. Right? Point of inflection. Okay, the point of inflection, as I told you yesterday, you get it by finding the second derivative. So our first derivative, okay, our function is x cubed minus 2x squared minus 4x plus 8. Alright? Then the first derivative will be equal to 3x squared minus 4x minus 4. I'm using rules of differentiation, not first principles. You only use first principles if you are told to do so. If you are not told, use the rules. Then the second derivative, it will be 6x minus 4. Okay? So this is the first derivative. And this one here is the second derivative. Okay? Now, we equate the second derivative to 0 to solve for x. So, we say 6x minus 4 equal to 0. You get 6x equal to 4. Divide both sides by 6. Get x equal to 2 over 3. Okay? I'm not done. I need to find the y value. Okay? Where this x is. So, to find that y value, yes. Did you go over yesterday's lesson?
It's also funny right now.
The point of inflection, you get it. If you find the second derivative and you equate it to 0, then you solve for x. Then that x value you substitute into the original function. That's why yesterday I didn't give you homework, I didn't do anything else. I spoke about the properties. Yes. So those are the reasons. So that when you get home, you go over it so that you are ready for the next lesson. Right? So here, this x value, we have to substitute back there. Don't substitute into the first derivative or into the second derivative. So it becomes f of 2 over 3 will be equal to 2 over 3 cubed minus 2 times 2 over 3 squared, right, minus 4 times 2 over 3 plus 8. What answer do you get? Can someone get the answer for us? It has to be a common fraction. You're all supposed to have your calculators in front of you. Right? You're all supposed to have your calculators in front of you. Alright. So what this means is that my point of inflection here, I'll write it here, is going to be at x equal to 2 over 3, right? And y equal to 128 over 27. Now this is close to 4. Okay? Close to 4. Right? So let's sketch now. We are ready to sketch. We have got all the information, so let's sketch. Okay? So I've got my graph ready. Okay? I've got my graph ready. So the first thing, let's identify the x-intercept. So I said x equal to 2 is here. At this point here, we also have a stationary point here. Okay? Then we've also found x equal to, we go back just to check. X equal to 2, okay. Then minus 2, yes. Minus what? Minus 2. Right? So minus 2 is here. That's where the other x-intercept is. Remember, the shape of our graph, it starts with a maximum, then a what? Minimum. So it starts somewhere at the bottom here, then it goes like that. Our y-intercept is here. Okay, let me represent that with a different color, maybe blue is better. So our y-intercept is there. Then we have a stationary point where x is 2, what's the value of y? Stationary point where x is 2, what's the value?
0.
Huh? 0. So this is also a stationary point. Right? Then we have a second turning point or stationary point. What's the value of x?
Negative 2.
Negative 2 over 3. Negative 2 over 3 is somewhere there. Right? What's the value of y there? Okay.
About 10.
Can you round it off to the negative to okay, so I would probably maybe put it, is it positive?
Yes.
Okay, so negative 2 over 3 is somewhere there. So I can put it maybe somewhere there.
It's 9.
Oh, it's 9. Okay, so it will be right at the top. So maybe it's 9 comma what?
5.
9 comma 5. So somewhere there. Yeah, it's somewhere the 9 comma 5. Where?
That's 9. Yeah, that is 0.
Okay. Somewhere there. Right. Okay. So let's sketch now. Right. So when you sketch it, right, let me use well color. When you sketch, it starts from the bottom. Remember, this is an x-intercept, so it goes like this, and then it turns. This is a turning point. Let me start it. Let me start it now. Then it goes. Then it will turn. Okay. Goes like that. So the graph will look like that. Okay. This point here is both an x-intercept and a turning point. Like if you want, we can just put the coordinates here. You say its x is minus 2 over 3 and 256, am I right? Over 27, right? And here, while here it will be 2, 0. Okay, obviously, that will be 2, 0. So it will look like that. Then we label it f of x equal to, okay, you can label it completely. That will be 2x squared minus 4x plus 8. Alright, so I sketched it. Yes. No, this is the y-intercept. Go back to where I first started. The y-intercept. Okay? That will be the y-intercept. Alright, now, let's do some analysis. Right? Now that we have sketched, you can answer questions. Let's say you get a question saying, for what values of x, or rather we forgot the point of inflection. In fact, I was supposed to have included the point of inflection first. Right? It's what's the value of x at the point? 2 over 3. Positive. Okay, that will be somewhere. Okay, this will be 1 here. Well, let me just approximate it. Right. What is 127 over what?
27.
4,8. 4,8, well, maybe somewhere there, approximately, all right? This is not exact. So x is 2 over 3 and 127. 120 what? 8.
Over 27.
128 over 27. Alright, so we have our point of inflection. Alright, let's say if the function says for what values of x is the graph concave down, right? Concave what? Concave down is this one up to there. It means it's when x, so this is our point of inflection, right? We have a maximum turning point here, so the graph is concave down until this point here where you've got a point of inflection. So our answer there will be x is less than 2 over 3, right? But if you think that you can get confused there, find your second derivative. I'm sure you saw me finding the second derivative. It's f double prime of x, okay? It's equal to 6x minus 4. Am I right? Then you say, yesterday I gave you an inequality. If you want to determine for what values of x the graph is concave down, you just equate the second derivative by saying it's less than what? 0. So f double prime of x must be less than 0. So we say 6x minus 4 is less than 0. Then you solve this, you get 6x is less than 4. You divide both sides by 6, and you get x is less than 2 over 3. This is by calculation, right? Can you pay attention, please? This is by what?
Calculation.
By calculation. You can also get it from the graph if you understand your graph. It is concave down to the left of the point of inflection, so all the values to the left of the point of inflection, they are less than 2 over 3. So to the right, the graph will be concave what? Up. So here it's concave down, right? To the right, it's concave up, right? To the right of the point of inflection, it's concave up. So your second derivative must be greater than 0, which means 6x minus 4 is greater than 0. Therefore, 6x is greater than 4, and then you divide both sides by 6, you get x is greater than 2 over 3. You can also get that answer from the graph. To the right of the point of inflection, the graph is concave up, which means all the values of x are greater than 2 over 3. Okay? That's one type of equation. Either it can be on concave down or what? Concave up. Not both. They will bring one of the two. Okay? Either concave down or up. Another question that you can also get is, for what values of x is the graph a decreasing function? Okay? For what values of x is the graph a decreasing function? In that case, you look at the turning points. It's talking about increasing or decreasing. You look at the what? Turning points. The gradient is negative because that's an indicator that is decreasing. The value of x there, you say decreasing between what values? The value of x at the first turning point is 2 over 3. Is less than x, is less than the value of x there, which is 2. That would be your answer there. It is decreasing between minus 2 over 3 and positive 2.
What is the question for that one?
For what values of x is the graph decreasing? Okay? It is decreasing when the gradient is negative. Okay? I just want to remind that I've already studied interpretation. That's what's called interpretation now. So once you can skate, you should be able to interpret your graph.